Hello students, welcome to Samclasses. So in this video, we'll be solving the questions of Exemplar on determinants. Now we went a bit fast since it was a crash on the PYQ section, but in this Exemplar, we'll go slowly and slowly. We'll understand each and every concept and then we'll build our base, okay? So the Exemplar series will be to build your base. So take time, do it properly, understanding each and every line, okay, and then do it. Clear? So that is the most important thing. In the PYQ section, we have a target to finish like each question in less than 30 seconds. But here in the Exemplar one, we have time. Here is basically we do so that we can improve the understanding, the concept of our base, okay, so that we can make a rock solid base for the maths part and we don't do any or we don't commit any kind of mistake in the exam. So let's see the first question here, student. So what is it given? Simple determinant question, just in form of variable, okay, and they want us to solve it. So nothing is there in this question, but while solving, always understand my target will be to produce as many as zeros before expanding it. So first target will write it ourselves is to produce more number of zeros before expanding. Okay, so this is one of our prime target. Okay, so let's write it down. Now how can we make more zeros? So if you see this one and this one, both are same, student, correct? So what we can do, column 2 is equal to column 2 minus column 1. Somebody will say, sir, what if we do, sir, column 1 is equal to column 1 minus column 2? Same thing, student, okay? Either you make this side 0 or that side 0, both are same, okay? So what you have to do is, so what I'm doing is this, let's say do this one only, okay? Column 1 is equal to column 1 minus column 2. So basically a change will occur in column 1, and what is that change? That column 1 will be subtracted by column 2. So I've taken the column 1 elements x square minus x plus 1, and then I've subtracted with x minus 1, okay? The first element of the column 1 is subtracted with the first element of the column 2, and the second element of the column 1 is subtracted with the second element of column 2. So x minus 1, x plus 1. So what we got here, student? X square. Now minus x minus 2x, and 1 plus 1 plus 2. Correct? We got this much. And then here x minus 1, here 0, student, and here x plus 1. Now we can simply, what? We can expand it, this into this, top to bottom, and minus bottom to top. But here you can see 0 is there, so we don't have to worry from bottom to top. So directly we'll just expand x plus 1 into x square minus 2x plus 2. Correct? That's it done. That only we have. So if you want, we can open it up also. Let's open it up, multiply it. So x cube minus 2x square plus 2x, and then here we'll get plus x square minus 2x plus 2. Correct? So what you'll get? X cube. Now minus 2x square plus x square minus x square. 2x and 2x got cancelled, plus 2. So very simple answer we got it, student. Okay, nothing much was there. So understanding each and every line is the most important thing in the exemplar section, okay, so that your base becomes very strong. And the fear with the maths, okay, a lot of students, they have fear with the maths. The moment they see, they're like, sir, maths, sir, we can't do it, okay? So we have to remove that fear. Nothing is there, okay? Don't worry about the answer. Each line by line will try to understand how after one line I'm going to the next line, and if I understand that much, I'll be able to solve the question. Okay, let's proceed to the next question. The next question, student, as you can see, it is looks up pretty much, what is it, complex, correct? You'll be like, so what is there? Okay, but if you see it a bit carefully, on careful inspection, what you can understand is, if this 3x is subtracted by 1x and one more x, so I'll get 1x single, okay, and then y plus z will be there. So I'll be able to generate x plus y plus z in all of it, correct? If I see this one, and if I add this and this, I'll be able to get x plus y plus z. If I do the same thing here, I'll be able to get again x plus y plus z, correct? So you need to see and you need to be very vigilant in here. Okay, you don't have to panic by seeing the question. So most of the times either by addition of columns or by subtraction or by addition of rows, we'll be able to generate something common, make it in simpler terms, try to bring more and more zeros and expand it. That is our every time the main aim. Nothing more than that, student. Okay. So first what we are doing, column 1 is equal to column 1 plus column 2 plus column 3. Okay. So what you have done is, so 3x minus x plus y minus x plus z. Okay. I'm just showing it for the first one. The rest one, I think so you understood. Okay. Again, it will be x plus y plus z. Now this is same, x plus y minus of 3y, y minus z, minus x plus z, z minus y, and 3z. Okay. Now understand the concept. Again, what will happen? So we got x plus y plus z. In all three of it, we took it out. X plus y plus z. So what we got, student, here? 1, 1, 1 minus x plus y, 3y, y minus z, minus x plus z, z minus y, and 3z. So we got this much, student. Correct. Now what we can do here, now next target, what I told you, student, before expanding, try to make more zeros. So if I subtract these two from the first row, I'll be able to generate zeros. Correct. So what I'm gonna do, that row 2 is equal to row 2 minus row 1. Okay, and row third is equal to row third minus row 1 again. So the moment I took it, so x plus y plus z. Okay, so things will be going a bit out of paper. I have to add one extra sheet, but let's see, who cares about that. Correct. Now minus x plus y. Okay, if you subtract 3y minus y, so it will be 2y minus x. Correct. And if you subtract from top, y is gone, so minus z plus x. Okay. Now if you do here minus x plus z, if you subtract minus y plus x, and the last one will be what do you say, 2z plus x. Correct, student? Very simple. Now we already got two zeros, so we'll be expanding along this. So leave that row, leave that column, this into this, top to bottom minus bottom to top. So x plus y plus z into multiplication of 2y minus x into 2z plus x. Now put a bracket like this, minus of x minus z into x minus y. Got it, student? Okay, I'm not opening it a lot. If you want, you can open it up. Okay, so if you open it up, what you'll be getting is, you'll be getting what you say. If you try to solve it, x plus y plus z. Okay, let's open it up. What is that? Multiply, so what you'll get? 4zy minus what do you say, plus 2xy minus 2xz minus x square. Correct. Then what we are getting here, minus x square. Correct, we are getting. Okay, now what else we are getting here, student? Okay, I think so. Let's see, student. Or when I did this one is plus y. That's why I thought something this, because x square term will vanish. So minus x square minus, okay, so plus xz, student. Okay, plus yz minus xz we did. Okay, so xy we didn't do, no? Xy. Okay, now let's see. This will be minus yz. Done. So if we solve it, student, what you will get? X plus y plus z and 3 times of what you say, yz. Okay, because 4zy minus zy. Okay, plus 3yx plus 3xz. Done. So very simple. Okay, nothing tough was there in this. Okay, now let's see the next question. Again, this question, the diagonal elements are same, students. Okay, and the rest other elements are x, x, x. So what we have to do, what we can do. So first let's see what we're going to do is, we'll do row 1 is equal to row 1 plus row 2. Now why are we doing it? You'll be able to understand. Let's see. So if I add row 1 and row 2, what I'll get, student? 2x plus 4, 2x plus 4, and I'll get here 2x. here x plus 4, x, x plus 4. Correct. We got till here. Okay. Now what I can do, student, is, now what I have is, this I can write it as 2x plus 0 also. Okay. I'll expand it. Okay. The property in the determinant by which if any row or column is written as a sum of two or more elements, I can make, what is it, separate determinants. So 2x, x, 2x, x, 2x, x plus 4. Correct. And x plus 4 here also. Correct. Now plus 4x, 4x plus 4x, 0x, x plus 4. Correct. Now what you can see, student, we got a very simple form. Now what you have to do? See, in the first one, you'll be able to take easily 2x common. So take 2x out. Correct. So the moment you took 2x out, 1, x plus 4, x plus 4. Correct. Now here you can take 4 out. So 1, 0, x plus 4, x plus 4. Correct. Now what we can do, student, we'll try to make zeros. So we'll try to make this one 0 and this one 0. We'll subtract C2 is equal to C2 minus C1 and C3 is equal to C3 minus C1. Pretty simple. Column third will subtract. So 2x into here 1x, 0, 0. So 4, again 0, 0 and 4. See, very simple. We can easily expand it and get the answer. Plus, again we'll make here also same thing. So we'll just do for one of that. Okay, we don't have to do for all of it. Just one will make it 0. Okay, so 4 into 1x and 0. Okay, so this one will be 4 and again 0. So 0x plus 4. So if we try to solve it, let's solve it on top here. Okay, so 2x into, we can expand along this. So just 16. Correct. Plus 4 into, we can expand along this. So 4 into 4, so 16 into x plus 4. So 32x plus 16x plus 64. So how much we are getting? 48x plus 64. So done. Any doubt? Very simple question. Correct. So let's see the next question. Now the next question, if you see, it looks a bit scary. What do you say? Correct. So it's not that scary, but we need to understand how to do it. So first thing is, if I add all the three rows, row 1 plus row 2 plus row 3, will I be able to get a plus b plus c? I can say yes. So let's do it. So row 1 is equal to what, students? Row 1 plus row 2 plus row 3. Okay. Add all the three. So you'll get a plus b plus c. Again here a plus b plus c. Again a plus b plus c. Correct. So 2b here, 2c here, b minus c minus a, 2c, 2b and c minus a minus b. Okay. So next step will be what? Take a plus b plus c out. Correct. So the moment we took it out, now we are left with 1, 1, 1, 2b, 2c, b minus c minus a, 2c, 2b, c minus a minus b. Very simple. Now again, I told you everywhere, see, the determinants are pretty simple. The concept is what? To make 0. To make 0, let's make more zeros. Correct. So the moment we try to make zeros, it will be what? What we will do? Column wise or row wise, student? Column wise is more better. So column 1 is equal to column 1 minus column 3. And column 2 is equal to column 2 minus column 3. Now try to always, like, important thing is here. Try to change only 2 rows or only 2 columns. Keep 1 row or 1 column unchanged, student. Okay. Now, so what will happen? 0, 0. Okay. And this will be a plus b plus c. Correct. Because I'm subtracting this to this. So 2c minus c is c, and then minus a and minus, so a, and minus b and minus, so a plus b plus c. Again here 0. And if I subtract with what is it, 2b, so we'll get minus of a plus b plus c. See how easily it is coming up. Okay, you don't have to worry about anything. Step by step, whatever you are able to see, do that one, and the next step will be very clear. So we try to visualize the whole answer. It sometimes becomes too difficult. Okay. Now we already have a plus b plus c out. So we'll try to take this one out and this one out. So what we can get, student, or we can expand along this because already we got two zeros, correct? So a plus b plus c into 1 and then this into this is 0. We don't have minus top to bottom, so minus and minus will be cancelled. A plus b plus c the whole square. So basically what we got, student, here, a plus b plus c the whole cube. See how easy it was. Okay, the whole thing was nothing, just simple few steps, and it didn't took much time also. So here I'm just doing it slowly so that you are able to understand in a good manner. You can make a practice. Okay, and in KCET exam or in any other exam, you'll be able to apply. Okay, your target is to apply that time fast. You can do a lot of stuff which I'm doing here by writing in your mental in your mind only. You don't have to write each and every step. Okay, now let's see this question, student. The moment you got this question, what are you going to do? So first thing is we can try to make more and more zeros so that while expanding it becomes very simple. If nothing comes up in mind, we can do this one. Correct. So what we can do? Column 1 is equal to column 1 minus column 2. Correct. So what you will get? 0 minus 7 14 1 3 minus 7 sine 3 theta cos 2 theta and minus 2. Okay, we have already given that this is equal to 0. Correct. Now what we'll do, we can take 7 common and we can expand. So the moment I took 7 common, what I'll get? 0 minus 1 2 1 3 minus 7 sine 3 theta cos 2 theta and minus 2. Correct. Now what I'll do, I'll expand. So 7, keep it outside. So this no need to expand. Now for this minus 1, so minus 1 into, leave that row, leave that column. So what I'm getting? Minus 2 plus 7 sine 3 theta. Correct. Now this is what? Which? Plus minus plus, then this is minus, so plus it became. Okay, and then so here it will be what? 3 1, so plus. Okay, 2 into this row, this column, we leave it. So cos 2 theta minus 3 sine 3 theta. Correct, and that is equal to 0. So what do you got? 7 minus 2 plus 7 sine 3 theta plus 2 cos 2 theta minus 6 sine 3 theta. Correct, is equal to 0. Now 7 sine 3 theta and minus 6 sine 3 theta. What we can do? This will be minus 14 and 7 minus 6 is 1. So plus 7 sine 3 theta plus 14 cos 2 theta is equal to 0. Correct. So send that 14 that side and you can divide whole thing by 7. So 7 1 7 2 and this again 2. So sine 3 theta plus 2 cos 2 theta is equal to 2. So pretty simple. Till here we are able to understand. It became pretty simple, student. Correct. Now what we'll do, we'll try to make either a quadratic or a cubic equation so that we can use the formula and solve it by a quadratic or a cubic method. Now sine 3 theta can be written as what? 3 sine theta minus 4 sine cube theta. Correct. And cos 2 theta can be written as what? 1 minus 2 sine square theta. Correct. Now see, the whole thing either came into cos, you make it, or whole thing you make it into terms of sine. Now I made everything in terms of sine only. Correct. So what I got is minus 4 sine cube theta, minus 4 sine square theta plus 3 sine theta is equal to 2 minus 2 is 0. So if I take care of the minus, so I'll get like this. Correct. Now what I'll do? Quadratic method. Okay. First I'll take sine theta common. Sine theta, the moment I took common, so 4 sine square theta plus 4 sine theta minus 3 equal to 0. So one option what you can get here is either sine theta is equal to 0. So if theta is equal to 0, then it will be equal to what, student? n pi, or this whole thing is equal to 0. So you have to solve. So what we will use? Quadratic formula. No, nothing else. What is the formula? You remember, minus b plus minus of root d by 2a. So minus 4 plus minus of root under of 16 plus 48 by 8. Correct. So that is equal to minus 4 plus or minus of root 64 by 8. So that is equal to 4 by 8 or minus 12 by 8. Correct. So we are getting two values. One value is half and the other value is minus 3 by 2. Correct. So half corresponds to what? Pi by 6. When is sine half? 30 degree. Correct. And sine minus 3 by 2 can't be possible because sine value max is what, student? Sine lies from what? Minus 1 to 1. So here it is minus half. Minus 3 by 2. Okay, so that is not possible. So answer is this one. Okay. Clear? No doubt about it. Now the question is telling that A1, A2, A3 up to A are there in GP. We have to prove that this one. Okay. So we know AR term is equal to what in GP? AR power n minus A, capital A power R minus 1, term minus 1. Correct. So AR plus 1 will be what? 1 less. So AR power R. Correct. So by this, the moment you understand this concept, because fifth term can be written as what? A R power 4. Okay. Correct. So that logic, if I am writing A R plus 1th term, that will be what? Capital A into R plus R power R. 1 less than that. Okay. So this whole thing I'll start expressing in terms of A R power R, A R power, what it will be? R plus 7 means what? R plus 6. Correct. So A R power R plus 10. Okay. So the moment you are able to understand this concept, the whole question is nothing. Okay. So AR power R plus 10, AR power 1 less R plus 16. Same thing, AR power R plus 8, AR power R plus 14, AR power R plus 20. So what you can do from whole of this is take from the first one, what you can take common? Tell me. If I take AR power R in the first row, if I take AR power R as common, what we will get? This will be AR power R I took common from the first. From the second row, I took AR power R plus 6 because the minimum was that. And from the third row, AR power R plus 10. So the moment I took this, I got 1, 1, 1. AR power, how much? AR power R I took. So AR power 4 is left. Okay, now a lot of students, they'll have difficulty like how we have done this. So basically how we have done, understand it. Okay, it's pretty simple, nothing tough is there. A R power R we have taken. So if I multiply this with whole thing with R power 4, so what you'll get? A R power R plus 4, correct. So we have already taken, what do you say? A R power R, correct. So what will happen now? So it will be just R power 4. Here it will be what? R power 4. Here also R power 4. Now I don't have to solve the other part. I'll just take R power 4 also outside. So I'll get here 1, 1, 1. So two columns are identical. Now you can understand directly 0. So the question looked very difficult from the outside. The moment you wrote few basic steps, you are able to what? Decode the whole problem. Okay. So first thing we need to understand is how do we write a general term? Rth term is written as AR power R minus 1. Correct. The moment we know that, then AR plus 1th term will be written as what? AR power 1 less R. So A fifth term we already know is what? AR power 4. So that way AR power R plus 1 will be what? AR power R. And AR power 7 will be what? AR power R plus 6. Done. So the moment you understand that, taking common and then getting the answer. Now let's see this question, students. We have already solved this question in the determinant PYQ section in 2018. determinant PYQ video, okay, PYQ. So go through that video, okay. We have given you one simple method, one shortcut method to solve it in under 30 seconds, okay. We have given you two methods to solve under 30 seconds, very simple, okay. Now let's see the next question. Here the question, okay, and the option also looks very big, pretty big, correct? So don't get scared by seeing the question and the option, okay? It's pretty simple question. Whatever you can visualize by seeing it, you'll be, whatever the next step you can see, try to do that, okay? Let's say I don't know how to proceed. So what I'll go through, let's see the first column of this. What is it given? Can I take something common? In most of these cases, can I take something common? Okay. So from the first column, what do you think? What I can take common? Any idea, students? Think a bit about, okay. Try to do this question without seeing the video. Okay. So it will be a great help to you and you'll be able to understand in a much faster manner. Okay. Try to do it without seeing. Now, the moment I see that I can take from the first column B common. So B done. So B minus A. Again took A common, so B minus A. Again took, C common, so B minus A. See how easy it got. Now B minus C, A minus B, C minus A. And here again I took C common, so B minus A. Again I took B common, so B minus A. Again I took A common, so B minus A. See, was it that difficult? No. Just took both from this column, take this B minus A, and from this column also take this. So what I'll get? B minus A the whole square, and I'll get BAC, B minus C, A minus B, C minus A, and CBA. Correct. We got till here. Now what we want to do is try to make more and more of zeros. Correct. What we have to do? Try to make more and more zeros. So how will we make it? Let's see. Now, if I subtract student C1 minus C1 equal to C1 minus C3. So if I see that, I'm able to make B minus C, A minus B, and C minus A, which is exactly same as the second column. The moment I do that, and the question is done. See, the question looked very difficult, correct? So what is the answer? None of these, okay? So it looked very difficult, but inside nothing is there. You just have to understand and take common, get a bit of strength. Just taking common, the moment you are able to separate it, you'll be able to view, oh, if I subtract this, if I subtract this, if I subtract this, I'll be able to generate the second column only. And that will be directly, two columns will be identical and I'll be able to solve the question. Now let's see the next question. What is here in this question? Sine and cos is given and some interval is given. Now nothing common we can take, but if I add all this, they'll give me some simple common thing. What I'll do? Column 1 is equal to what? Column 1 plus column 2 plus column 3. So what I'm getting? 2 cos x plus sin x, correct? Here again we are getting 2 cos x plus sin x. Here again we are getting 2 cos x plus sin x. So pretty simple. Cos x. So whatever you are able to understand from the first step, do it. Forget about what you're going to do after that. Okay. Once you do that, take common, you'll be able to visualize. Okay. You'll be able to see, oh, it became so easy. So the moment you took 2 cos x plus sin x, so what you got? 1, 1, 1 here. Cos x, sin x, cos x, cos x, cos x, sin x. Now what is the next target? To make this and the 0. Every time. It's almost similar, student. Okay. So the moment you do that, so 2 cos x plus sin x, and the moment you do what is I'm writing here, 0, 0, cos x, it will be sin x minus cos x. It will be cos x minus sin x. Again cos x, again sin x. Okay. So you got 2 cos x plus sin x. Okay. And then here you got 1, 0, 0. Now what you can do? You can expand. Along which this column. Okay, so first row, first column. So this into this minus this into this. So what will be? 1 into sin x minus cos x into sin x minus cos x into cos x minus sin x. So let's see what we are getting. Okay. So what we are getting here is sin square x minus sin x cos x. minus cos square x plus sin x cos x. So if you see, this one is getting cut. Now sin square x minus cos square x, how much, students? So we got two things, 2 cos x plus sin x, and here sin square x minus cos square x. So what we're going to do is, this is equal to 0. So we can say that either this part is 0. If product of two things is equal to 0, we can say either the first is 0 or the second is 0. So the moment we say 2 cos x plus sin x is equal to 0, so what do you get? 2 cos x is equal to minus sin x. Divide whole thing by what? Cos x. So what you'll get? 2 is equal to, or divided whole thing with by minus 2. Cos, what do you say? Minus cos x. So minus 2 is equal to tan x. So we know that tan x can never be minus 2 from this domain, because what? Tan x is minus 1 and 1 at tan pi by 4, 45 degrees, what? One value. So it's between minus 1 to 1. So this value is rejected. Now we got sin square x is equal to cos square x. Correct. So sin square x is equal to cos square x. This can only happen if it means that sin x is equal to cos x. So it can only happen when tan x equal to 1, and that means that x is equal to pi by 4. So it has only one root, and that is equal to what? Pi by 4. So how many distinct real roots it has? Only one. Okay. Now let's see this question. The maximum value you have to find, okay, of this. So let's first try to make it in a more simple form. So what we'll do, try to make zeros. So C1 is equal to C2, C1 minus C3, correct. And what we can do, C2 is equal to C2 minus C3. So what we got, 0, 0, cos theta, 0, sin theta, 0, 1, 1, 1. Now we can expand along the cos theta, correct. So what you will get, or we can expand along 1, whichever you want, we can expand along, okay. So what we are getting here is sin theta into cos theta, correct. Pretty simple. Now what we're going to do, multiply with 2 and then half. Now a lot of students are, why are we doing this? Because we need only in one term, not sin and cos, because it becomes very easy to find the maximum value of one single trigonometric function rather than two. Okay, so the moment you write it like that, you will get sin 2 theta. Now you can say the maximum value of sin 2 theta is what? The maximum value of sin theta is 1. So maximum value of sin 2 theta is also 1. And for what value? Sin theta we were getting maximum at theta equal to 90. So 2 theta equal to 90. So theta is equal to what? 45 degree. Correct. So what is the value? We are getting the maximum value for which theta is a real number. Correct. So that is equal to what? Half, because this max value is 1. So we'll get the value as half. Correct. Done. So since they haven't asked what is the value of theta, if they would have asked, we could have said this answer also. Okay, we could have used this part also. Now in this question, they're telling that find the value of lambda for which A inverse exists. Now for A inverse to exist, what will happen? The det A should not be equal to 0. So what we'll do, we'll try to direct expand it. Okay, correct. Or we can make a bit more zeros. So if I make a bit more zeros, what do you say? We can make this one as 0, correct? And anything else? No. So what we can do? 2, 0, 1. This will be lambda minus 2, again 2 and 0. And this will be, if I subtract, will I be able to, what do you say? Leave it like that, because I won't be able to generate much zeros. Okay. So now I'll expand along this 2 first. Okay. Or I can expand along this also, whichever I want. So let's expand along this. So for this first one, 1, it will be 5 into lambda minus 2 minus 3 into 2, correct. And then 0 is gone, plus 3 into, for this, okay, it is 4 minus 0, correct. So, and this should not be equal to 0. So 5 lambda minus 10 plus 6 plus 12 should not be equal to what? 0, correct. So 5 lambda and what do we got? 18. 18 minus 10 is 8. So 5 lambda plus 8 should not be equal to 0. So 5 lambda is not equal to minus 8. So lambda should not be equal to minus 8 by 5. Correct? So the inverse will exist only and only if the value of lambda is not equal to minus 8 by 5. So none of the options, okay? But pretty simple question. Now a very conceptual question here. A and B, they have said it is invertible matrices, okay? Then which of the following options are correct? So we know A and B are invertible. So what we can do? AB whole inverse can be written as what? B inverse into A inverse. Now since it is invertible, so A inverse can be written as what? Adjoint of A by det A. Just I'm putting up the formulas, okay? So from here we can get adjoint of A is equal to det A into A inverse. Any doubt in this? Nothing. So what we got is det A, what do you say? And we also know that det A, determinant of A inverse, is equal to 1 by determinant of A. Correct. This also we know it. So this also is clear, this also is correct, and this also is correct, okay? And adjoint of A is equal to this also is correct. So this is wrong. A plus B whole inverse is equal to, we can say that 1 by A plus B determinant into adjoint of A plus B. It is never and never equal to what you say B inverse plus A inverse. That is only possible in case of matrix multiplication, students, okay? So be very careful about it. Very simple question, okay? If you remember the formulas properly, you would have been able to solve this question without any difficulty. Now by looking at this question, student, what we can see, if I add all the three, what you say, columns, we'll be able to get very common thing, what? 3x plus 3y, correct? Let's do it. So C1 is equal to C1 plus C2 plus C3. So what you'll get? 3 of x plus y. So 3 of x plus y and 3 of x plus y. This is equal to x plus y, x plus 2y, x plus 2y, x plus y and x. Now take it out. So the moment you took it out, 3 of x plus y, what you got? 1, 1, 1, x plus y, x plus 2y, x plus 2y, x plus y and x. So the moment you got this, what is your next target? I told you, try to make more and more of zeros, and then the expansion becomes very simple. So I'll make this one 0 and this one 0. So the moment I do 3 of x plus y, and then it will be 1, 0, 0. So what will happen? X plus y, and this will be what? Minus y, and this will be just y. This will be again x plus 2y. This will be minus y, and this will be minus 2y. Correct. Now if I want, I can take both the y's outside. So I'll take y. So y square. The moment I took y, it will be 1, 1, again 1, and then minus 2. Correct. Now it became very simple question. If I want, I can just expand along this. So take this, leave this. So what you are getting, this into this. So that is basically minus 1 into minus 2 minus 1 into 1. So plus, so 2 plus 1, so that is equal to 3. So 9 y square into x plus y. See how beautiful and how simple the problem was, okay? So by seeing it, you are able to deduce it, and you are able to solve it, okay? Let's see the next question. We have to find the value of A for which the determinant is equal to 86. The sum of these numbers is, okay? So let's see what they're trying to find. First, we have to find the value of A. So very simple, what we'll do, we'll try to expand along some row or column, okay? Now, can we make some zeros and make it more simpler? It doesn't look we can do much simplicity here. So we'll just expand, okay? So 1 into, if I expand along this, it will be what? A square minus plus 4, and then, it's 2a square, okay? My bad. Minus 2 into, okay, and minus 4a minus 20 plus 0, correct? And that is equal to 86. They've already given. So 2a square plus 8a plus 44 is equal to 86. So what we got? 2a square plus 8a minus 21 is equal to minus 42 is equal to 0. So take 2 common. So a square plus 4a minus 21 equal to 0. Now after doing this, a lot of people, they don't know middle term factor. So let me just tell you, 21 will take AC, product of AC. Last two terms, this one is 1 and this one is 21. So what are the factors? 7 and 3. So 7 minus 3 is what? 4. So a square minus plus 7a minus 3a minus 21 will do. So we'll get a equal to minus 7 and a equal to 3. Correct. Now they're telling that what is the sum of this. Okay, so sum of these numbers. So 7 minus 7 plus 3 is how much? Minus 4. So very simple question. Any difficulty in this? I don't think so. Simple was it is. It was like you had to expand once you got the values, like two values, you got a quadratic in A. So you got two values of A, then add it up and then tell the sum of it. Okay. Now a very similar question we have done, students, in the PYQ determinant section, okay, of what is it, 2020, I think so, or 2019, okay, of KCET. So very simple question, the answer will be equal to 0. Okay, what you have to do, you already know that there also I told you the concept, ax plus a power minus x. If I open it up, what I'll get, a power 2x plus a power minus 2x plus 2, and this side I'll get, if I have minus, okay, so pretty simple, nothing is much here. What do you say, plus a power minus 2x minus 2. So if I subtract these two, students, I'll get 4. Okay, so same thing, I'll get like 4 4 4 here and 1 1 1 here. So if I take 4 common, both the rows are what do you say, columns are identical, and directly the value of the determinant will be 0. So a lot of questions from the exemplar, just by changing the value, they're putting it in the KCET. So do solve each and every question of the exemplar, pause the video, write it down, think on that question and try to solve it. Try not to take use of the Google Chacha, okay, and try to do it by yourself, okay. So, and if you're not able to do, then look at the what is a solution video and then understand where you're going, what the difficulty you are having, and still after that, if you're not able to clarify, put it in the comment section. We'll try to make a video. We'll have a doubt live session, okay, very soon, and we'll try to clarify on that. Now in this question, students, they have already given cos 2 theta equal to 0. So a very important point, cos 2 theta is equal to 0. So when it can happen? So cos 0 is, when is cos 0? At what do you say, pi by 2, 90 degree. So 2 theta is equal to pi by 2. So we get theta is equal to pi by 4. Now substitute. So we know sin pi by 4 is equal to what? 1 by root 2. And cos pi by 4 is equal to what? Again 1 by root 2. So put the value and solve it. Nothing is there. So 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2, okay, 0, 1 by root 2, 0, 1 by root 2, correct. So now what is my main target is, if you see, what is the target here? Try to make zeros more and more. Okay, you can make more zeros here. So what you can do here, can we make more zeros? No, we'll be hampering it. It's like we can expand it. Okay, so expand along this. So minus half into, okay, so you'll get half, minus 1 by root 2, sorry, my half minus 0, correct, plus 1 by root 2, and then this time it will be 0 minus half, correct. So basically what we got, minus 1 by 2 root 2 minus 1 by 2 root 2. So if I do, so we'll get, what do you say, minus 1 by root 2. Now if I square it, students, what I'll get? Half, correct. Very simple question. So don't get too scared. A bit of trigger, if you know, you'll be able to solve it very smoothly. Now if a matrix is of order 3 cross 3. So matrix is what? Order of 3 cross 3. We have to find square. A square inverse will be equal to what? So we already know A square inverse is same thing as A inverse square, correct. So nothing more than that we can do here, correct? Now the next question here, student, again it's a very simple and very beautiful good concept question. A is a matrix of order 3 cross 3. So total 9 elements are there, 3 cross 3, so 9 elements. So the number of minors in the determinants of A. So if I make it into determinant, how many number of minors will be there? For each element 1 minor. So total 9 minors will be there. They just wanted you to know that if the order is 3 cross 3, So if I multiply, I'll get the total number of elements. So that same number of elements will be the same number of minus, nothing more than that. Now this is a very property question. The sum of products of elements of any row with its cofactor is equal to the value of the determinant. So if we have A11, A12, A13, okay, it's a 3 cross 3. So A11 into cofactor of that same plus A12 into cofactor of the corresponding element A12 plus A13 into cofactor of that gives you the value of the determinant. Okay, nothing more than that, student. This is the basic property. Correct. So that's it, basic property. Okay. Now let's see this question. Okay. Now this question, the moment you see, you'll see that the diagonal elements are 0. So by seeing the diagonal element 0, you'll think maybe it is a skew symmetric. But since this element and this element, they're not, what do you say, negative of each other. So we can say it is not a skew. So what we can do? Let's start with C1 is equal to column 1 is equal to column 1 minus column 3. So the moment I do this, what will happen? I'll get here Z minus X. Here also Z minus X. Because I saw if I subtract these two first and the third, I'll be able to generate Z minus X everywhere. Okay. X, Y, Z, 0. Z minus Y. X minus Z. Y minus Z and 0. Now what I'll do is, I'll just take it out common. So Z minus X, you take it out common. So 1, 1, 1, X, Y, Z, 0, Z minus Y, X minus Z, Y minus Z and 0. Now what I'm going to do is, I can expand. Now you'll say, sir, why not here also we make two zeros here and here. Now if I try to make a 0 here, I'll end up making, what do you say, this 0 some other value. And then this 0 some other value. Though I'll be able to make here 1 and 1 0, I'll be able to put up here minus xyz or minus y minus z. So it will be summing up to the same thing. So what are we going to do? Expand it. Okay. So let's see the expansion. So z minus x, expand it. So 1 into what we are getting here, leave this row, leave this column. Okay. So what are you getting? Z minus y into y minus z. So what we got? Z minus y into y minus z. Okay. Now, so and one minus sign because top to bottom minus bottom to top. Correct. Plus after this we'll expand along what? XYZ. So minus XYZ for the second sign, already we know sign convention. Correct. So minus XYZ. So leave this row and leave this column. So what we'll get? 1 minus 0 is 0 and minus, what do you say? This one will be y minus. So minus and minus we cancel, y minus z. Correct. Now coming to the last one, plus x minus z. Leave this row, leave this column. So we get, what do you say? Z minus y. Correct. Done. So z minus x, and then here, what I can take common, z minus y, z minus y. Here it is y minus z. Okay, so we can take z minus y common. So z minus y. So the moment I took z minus y, so what I'm getting here? Minus y plus z. Correct. Plus x, y, z. Now since I have taken z minus y, so here it will be minus x, y, z. And then here plus x minus z. Correct. So 1z went home. That's it. So what do you got? Z minus x. What do you say? Z minus y and y. What do you say? X minus y minus x, y, z. That's it. So that's the answer. So the moment you see this question, okay, you'll be like, sir, it's a very difficult question. We have so much of powers, and then that whole determinant value is equal to a plus bx plus cx square, and then it keeps going on. So it is like, what do you say, a troublesome question, okay? But it is nothing like that. So what do you have to do? What you can understand from this basic part is, I can take common. From each row, I can take common. So from each row, I can take 1 plus x whole power 17 out. Correct, that was the minimum value. So 1 plus x whole power 17, I'll take it out. From the second row, I'll take 1 plus x whole power 23. And from the third row, I'll take 1 plus x whole power 41. So what I'm going to get? 1, 1, 1. This will be 1 plus x whole square. 1 plus x whole power 6. 1 plus x whole power square. Again 1 plus x whole power 6. 1 plus x whole power, what is it, 23 I have taken, no? So 11 and 1 plus x whole power 6 here, okay? So if you can see that the first row and the third row are identical. So directly the value is what? 0. So this x and all that is like gone case and the value of a is simply 0. Okay. So the question looks so much big. Okay. And we thought the answer will be pretty damn big. So in a lot of cases, in 19 to 95% of the cases, or you can go to 99, the bigger the question, the easier it is to solve that question. Okay. So understand, don't be afraid of it. See what is the basic step, okay, the minimum step that you can do. So here the minimum step was from this first row we can take out what is the minimum which is common or the repeating unit from all three of it. So what we saw, 1 plus x whole power 17 was the minimum, okay, because every other had the, what do you say, more than that. So we can just take it out. So we took that one out. For the second row, we took 1 plus x whole power 23. And for the third, 1 plus x whole power 41. The moment you took these three out, you'll be able to see that first row and the third row, they are same and the value of the determinant is 0. So the basic constant term A is equal to 0. Now it's a true false question. A power n inverse is equal to A inverse power n. Correct. We already know this property and it is true. There's no doubt about it. Okay. Now students, we already know determinant of A inverse is not equal to, what do you say, determinant of A whole inverse. So this is fully wrong. Okay, it is false. So what is the exact answer? Can anyone say? Put it on the comment section. Very simple question. Okay, do comment it and put your answer on that. Okay, let's see how many students they know the answer. Now in this question, a very simple A and B matrices are of order 3. Det of A is equal to 5, det of B is equal to 3, and they have given det of 3AB is equal to 27 into 5 into 3, and that is equal to 405. They're asking whether it is correct or not. So we know det AB is very simple. We can just take it out. Det A into det B, correct. So that is pretty correct. But the moment we know 3 of AB, it means that inside the determinant, this 3 is multiplied to the matrix AB. So it means that it will come outside 27 of, what is it, AB. So that is equal to 27 of, or what is it, det AB, and that AB can be written as det A into det B. So done. We'll get the value 405, and that is correct. Now students, this question we have already solved in the determinant PYQ section, okay? In the determinant PYQ, okay, do check that video and you'll be able to solve all the other determinant PYQs also. We have put up the time stamping, so you won't have the difficulty to find the question and you can find it easily and you can check the answer. Now students, coming to this question, we already know the formula of this question. What is that? Determinant of adjoint of A is nothing but det of A power n minus 1. Now, what is this n? Correct. A lot of people will become, what is it thinking about? This is nothing but the order. If it is a 3 order, 3 cross 3 order matrix, so n equal to 3. So here they said the order is 2. So in that case, what will happen? Det of A power 2 minus 1. So that will be equal to det A only. So adjoint of determinant of adjoint of A in case of 2 cross 2 matrix will be just det A, not det A whole square. So again, it's a false answer. Now the determinant of a very big value they have given, sin A, cos B, cos A, sin B and all that. But we can see it's like a 10 seconds question, correct? So what are you going to do? Add these two. The moment you add these two, will it help? Can it help? No. Okay. So what are we going to do? Let's say we already remember a property in determinant. We can split up. If any row or column is written as a product of, what do you say, two elements, we can just split it up. So let's split it up. So we have sin A, sin B, sin C, cos A, cos A, cos A, and we have taken sin A, sin B, sine C. The moment you see this one plus, I've taken for the first determinant this one, and for the second one I'll take this sine A, sine B, sine C, cos A, cos A, cos A, and cos B, cos B, and cos B. So if I see this and this, the moment I take it out, they're proportional. It will be 1, 1, 1 and 1, 1, 1. So very easily you can say it is 0. This again, if I take it out, this again, what do you say? You don't have to take it out. This one and this one, identical both, directly 0. So 0 plus 0, it's what, the students? 0 only. No doubt about it. Nothing is there in this question. Okay. Now, a very similar question we have done in the PYQ section, students, correct? So let's see this question. If the value of a third order determinant is 12, so what they have given here, the value of a third order determinant is, they have given us 12. So let's see how do we solve it, okay? So this value is equal to 12. Now what they're telling, then the value of the determinant formed by replacing each element by its cofactor. So basically they're talking about the value of the determinant by replacing each element by its cofactor is nothing but adjoint, student, correct? So determinant of adjoint of A is equal to what? Determinant of adjoint of A is equal to det power n minus 1. Correct? We all know it. And det power n minus 1 will be what? Since it is a 3 order determinant, it will be 3 minus 1. So det power 2, and that is equal to 12 square, that is equal to 144. So correct, yes or no, students? Okay. So the value will be 144. Now students, we have already solved this question in the back side. Okay, previous question only. So the value was, what is a half, and the angle was 45 degree. Do check the previous question. Okay, in this video only you'll be able to solve it. Now what we have done, all important DPPs and PDFs we are providing in the WhatsApp group. The link is given in the description. Do check and join the WhatsApp group. And we have already, what is it, you can download all our notes, okay, on this website, onlinesamclasses, okay, .in. So do download it. Now students, once you have solved, make a short notes and upload it. We are trying to maintain each and every student's notes. So do upload your short notes so we can go through. They can see if there is any difficulty, any doubt, anything we can improvise and make it more better. Okay. And with the consistency, you'll be able to, what do you say, revise more faster, more better, and during the exam times, and that will help you a lot. So work hard, what do you say, and give your best.